Okay, so let's solve another example on the finding the square root of a radical. So we are dealing with sets, finding the square root of sets. That's what we are looking at. So in our previous lesson, we solved some examples. Let's also add more examples to what we already did. I think most students still have challenges. So let's solve this example as well. So my dear students, I will urge each and everyone to pay attention to this. We've already solved a lot of examples on this, but some of the students told me to um, go through this again. It seems most of them are still having some challenges. So let's look at this example. So when you are asked to find the square root, what we do is when we say square root, you know that this is what the square root, that is the radical sign for square root. All right, this is square root. So when you are asked to find the square root, it means that take whatever is given to you. You are finding square root, so it means you are going to put the whole of this in a square root. All right, but in doing that, you need to let it represent what, or you need to use variables also in square root form to represent this. You equate, then you can get what your answer. All right, but before you be able to solve this, you need to understand that if I should give you this, let's say 2 plus x is equal to um let's say y plus square root of 3. If I ask you to find x and y, what do you do? Now look at this. You see that you have these values, this here, this expression at the left side and this expression at the right side. Okay, so what you do is you look at the corresponding entities. So you could see that here there's addition here which is separating this 2. There's addition here which is separating this. All right, so looking at this, what you do is it means that you equate the first term here at the left side to the first term at the right side. So it means it's going to be this is equal to y. Have you gotten that? After that, then you equate the second term at the left side to the second term at the right side. So it means here to x is going to be what? Square root of 3. And we are going to use this principle to find the square root of this. If you know this, then you can work your way out. All right, great. So whenever you are given such example, when you are asked to find the square root of such example, what you do is you only let what is given to you in the question. Okay, so you are given what? 3 plus 20 root 2. You can let it be equal to, then you can choose what? Letters that you like. All right, so letters that you like, we can use, let's say, let me use P plus another one. Also we have what? Let me use Q. Good. So when you are asked to find the square root of this, so in my case, I decided to use P and Q. Someone can decide to use A and B. Others can also decide to use M and N or X and Y. It depends on you. Any letter you use can work for you. All right. So I choose P and Q. Now, so when you are asked to find the square root, all that you do is you let the entire work or question, this is given in the question, you let it what? To be what? Square root of any letter plus what? Square root of the another what? Letter. I'm using addition because looking at here, if you look at the example I did here, it means the first term should be equal to this, the second term should be equal to that. All right. So I'm using addition here because you see that addition is separating this. If here were to be um, subtraction, then I will also use what? Subtraction. All right. Great. So when you are asked to find the square root, first of all, what you do is choose this. Okay. Just choose square root of a letter plus square root of another letter. The letters should be different. All right. At the end of the day, we are going to find values for P and Q. And when you get the answer for P and Q, when you substitute, okay, when you substitute, it means that you are going to what, get the same what value here. All right, good. So the question says find the square root of this. So we don't know how to find square root. So what we do is we put the entire example in a square root because that's what the question demands. So I'm going to put the 33 plus 20 root 2. That's what the question demands. Okay, so the question says we should find what? Square root of this, which should be equal to, he said we should let this P plus Q. That is what we are talking about. You should let this, the square root of this, okay, to be equal to this. The reason why here I'm bringing, even in the first place, here, the square root, because here we are going to make here square root, that's why we brought this here. So it means the entire square root of 33 plus 20 root 2 should be equal to what? Square root of P plus square root of Q. That's what the question is saying. We should find square root of this. But how do we find square root of this? We have to let it be equal to this. Okay? And as you know, in our basic principles, we said that whenever you have radical symbols, what you do is you only what square both sides. Okay? You square both sides like this. Okay? So after letting the square root of this equal to this, please remember I said we brought this because that is what the question demands. The question says we should find square root of this. So this is the square root. Okay, this is the square root. So the square root of this, we should let it be equal to this. Okay, after that, since we know that once you have square roots here, you have square roots here, then we can square both sides because it involves what? Equal to, when we're doing what? The radical equations. When it involves equation like this and there are radical symbols, we take square of both sides. All right, great. So once we have this, then we can cross this out. Okay, having 33 plus 20 root 2, which is equal to, now remember what we did in the radical equations. When you have this, here comes again where most students make mistake again. When they see this, they will square this alone and square this alone. So in their case, they are going to get, after squaring this, here will be left with P, here will be left with what? Q. So they are going to get P plus Q, which is totally what? Wrong. I've already told you and have explained to you and I have given you examples how you go about this kind of example. So I don't expect you to make these examples whenever you are giving. I don't expect you to make mistakes, such mistakes and examples like this again. Yes. All right. So we are going to use the short way how I taught you when we're doing the radical equations. So I said that when you have this, it means that you can square the first term. So square the first term and then square what? The last term. Square the last term. Then what do we get in the middle? What you do is take the 2, so plus 2, okay, and multiply by the first term, multiply by the second term again, plus then this. So that is how you do it. All right, good. Now let's maintain our 33 plus 20 root 2, which is equal to, now if I should square this, then here becomes what? P. If I multiply this and this, remember that what we did in the basic principles of set, if I give you this square root of A times square root of b. We know that we multiply what is in the radical sign like this, so that we get what? Square root of ab. So it is the same thing here. We are going to multiply this by this. So we are going to get this, which is 2 times square root of p plus so we have even q, yes, because we are multiplying them, then plus, so this one will also go, then we have q here. All right, so very simple. Okay, now let's maintain this. Okay, plus 20 root 2, which is equal to, so I'm going to group like terms. I'm putting those which are singles without radicals one side, so I can write my p plus q and then put it in bracket like this, plus 2 root pq. Okay, good. So when you have this, then you can equate corresponding what entities. So you see that the first term, the addition is separating this, the addition is separating that. So you can equate the first term to the first term, the second term to the second term. So when you get here, you see that now this one comes in. Have you gotten the point? Great. So I will write my 33, which is equal to p plus q. Then call it equation 1. Okay. Then the second one, I'll write my 20 root 2, which is equal to what? 2 root pq. Okay. Now in this case, I can divide both sides by 2, which will give me 10 root 2, which is equal to what? Square root of pq. Now, we still have the radical symbol, so we need to let it go by squaring both sides. Okay, so if I'm squaring both sides, it means that this 10 will be squared, which is going to be 100. And then if I should then it is multiplying this one will also be squared, which is going to be 2, which is equal to this one will go, then I'll have my pq. So we have 200 is equal to pq. I can call this equation 2. Have you gotten that? So I'm going to solve these two equations simultaneously. But how do I solve this? I will use what? Substitution method. So from equation 1, I can make any of the letters the subject. So let me make P the subject. Okay. So I can say P is equal to 33 minus Q. Then I can call this equation 3. Now, once I have this equation 3, I can put equation 3 into equation 2 and solve. Okay, good. So if I'm putting equation 3, so put equation 3 into equation what? 2. So it means wherever I see P, I'll put 33 minus Q. All right, good. So I have this in equation 2. Now this becomes 33 minus Q times Q. All right, yes. So we do that, then we move on. Okay, good. Now let's move on. So I can open the brackets and get this. So 33 Q minus Q squared. Now I can group like terms to get Q squared minus 33 Q plus 200 is equal to 0. So this gives me quadratic equation. Now how can I solve quadratic equation? I can use graphical method. I can use quadratic formula, factorization method, different and then I can also use completing squares. Okay, but I'm going to use what? Factorization method. So you ask yourself, find the coefficient here. The coefficient here is 1. When I multiply by 200, I will get what? 200. So I find two factors of 200. When I multiply them, I must get 200. When I add them, I must get what? 33. So we can use this. So this is minus, I think I can use 25 and 8. Because when I multiply 25 by 8, I think I will get 200. All right? Yes. And when I add it, I will get negative 33. Okay? Good. So I can put this in one bracket. I can put this in another bracket. Have you gotten that? Then I'll factor Q out, where I have Q here minus 25. Okay? And then I can factor 8 out, and then I have my Q minus 25, which is equal to 0. Okay, great. So I'll put those outside. Now I have my Q minus 8, and then I have my Q minus 25. All right, good. So let's continue. Good. So I have my Q 8 and then Q minus 25. So it means that my Q minus 8 is equal to 0, or my Q minus 25 is equal to 0. So it means Q is equal to 8, or Q is equal to 25. Good. Now, once you have these two answers for Q, then we also look for what? P. At the end of the day, the values you are going to get for P should also be the same as what we have gotten for the Q. All right, good. So we can put this Q is equal to 8 into any of the equations. Okay, all right. So let me use equation 3. Okay, so this is equation 3. I can put Q is equal to 8 here. So I'll have P is equal to 33 minus 8, or P is equal to 33 minus, then I'll put 25 also there. Okay, which will give me P is equal to 25, or P is equal to what? 8. Good. So you see that we have the same values for Q. Have you gotten that? Good. So once you have these values, let's pick them and then go and substitute into the example and see if we will get the same values. Okay, so we are going to test. So this time, since they are all the same, we'll pick P is equal to 25, and then Q is equal to what? 8, and substitute. Okay, good. So we said that square root of this should be equal to this. We have now gotten what? The values of P and Q. So we are going to substitute this and check whether we will get the same as this. All right. Good. So let me maintain this. And then substitute the values. So we have square root of P. So Q is what? Or no, here is rather P, and here is Q. So P is 25 plus, and then we have Q as what? 8. 8. So we are testing to see if we will get the same value here, because that is what we said. Okay, good. So let me still maintain this. I have this plus 20 root 2, which is equal to, so root 25 gives me what? 5. All right, plus root 8 gives me what? 2 root what? 2. All right, remember, since we have this, we can take square root, and we can take square of both sides, so that this one will go. Then we have 33 plus 20 root 2, which is equal to, now we are going to take square of this. So we are squaring the first term, plus then we multiply 2 by 5, and then by what 2 root 2 plus, then we square the entire. So that is what we are doing. Okay, we are only testing whether what we will get here will be the same as this. So 33 plus 20 root 2 should be equal to, so here becomes what, 25. This times this gives me what, plus, so we have this times this is 10. 10 plus 10 times what, this is 10. 10 times this is what, 20 root 2, and then we can square this. This is 4, and this times this is also what, plus 8. Good. So we can write here 33 plus 20 root 2, which is equal to 25 plus 8. So I'm sending this here, then we add plus 20 root 2. Now we have 33 plus 20 root 2, which is equal to this plus this is 33 plus 20 root 2. Perfect. Now you see that we have gotten the same thing. So it means that this is how we find square root. Now all this you are doing here, this one is not part of the work. Okay, all this part, and it is not part of the work. The whole work ends here when you get the values for the Q and the P. It ends here. As for here, we are only testing to see whether it is true that the P is 25 and the Q is what, 8, because when we tested we got this. So when you are asked to find the square root of that, so it means that we are going to get 25 and 8. That will make the square root of what, 33 plus 20 root 2. Have you gotten that? So perfect, very wonderful. All right, okay, so see you next time. Thank you.